Given two numbers, a and b, we like to find the least number that they both measure. We call this the least common multiple. First, Euclid notes that a and b are either relatively prime or otherwise. We'll assume first that they are relatively prime. Multiply them together to get c. It turns out c is the least common multiple of a and b. If otherwise, a and b will measure a number less than c, say d. And we can write d as ae and bf. Thus ae is equal to bf, and thus a to b is proportional to f to e. Since a and b are relatively prime, a to b is in least numbers, so b measures e. Since ab is equal to c and ae is equal to d, b to e is proportional to c to d. b measuring e means c measures d, but this contradicts c being greater than d. So, if a and b are relatively prime, multiplying them together to get c gives the least common multiple. Now let a and b have a common measurer, and let f to e be the least numbers ratio of a to b. Thus ae is equal to bf, which product we'll call c. So both a and b measure c. It turns out that c is the least common multiple of a and b. If otherwise, let it be d and write d as ag or bh. Thus a to b is proportional to h to g. A to b is also proportional to e to f, so h to g is proportional to f to e. F to e is in least numbers, so f measures h and e measures g. ae is equal to c. ag is equal to d, so e to g is proportional to c to d. E measures g, so c measures d, which contradicts that c is greater than d. So c, equaling ae, equaling bf, is the least common multiple of a and b. To recap, if a and b are relatively prime, multiply them together. If otherwise, divide out the common measurer from one of them and then multiply it to the other.